The time domain reflectometer, or TDR, is used to test for faults which cause impedance mismatches in aircraft coaxial cables. Any impedance mismatch between the transmitter, the antenna, and the cable are cause for loss of transmission power. The TDR operates by sending a test signal through the length of the cable, and faults such as shorts or opens are reflected back to the TDR. Both the test signal and its reflections are displayed on the tester screen. American Airlines uses more than one type of TDR, and it's important to know where to find operators' information for each particular tester. The appropriate geyser or ground support equipment release can provide a wealth of information on test equipment such as the TDR. In this case, geyser number GR7026 contains information on the Textronics 1502B, including cable length parameters, correct power-up procedures for the tester, and detailed operator instructions. It also specifies kit 9022 for use with the tester. The kit contains adapter cables and connectors used to join aircraft cables to the tester. Familiarity with this geyser and the entire geyser system will help you obtain useful information on the TDR and other test equipment. The tester screen shows a grid, and the distance between each intersection is called a division. Horizontal divisions show the length of a cable. You can adjust horizontal scale from 1/10 of a foot per division up to 200 feet per division by using the distance/division control. Vertical divisions show the strength of a reflected test signal. You can adjust vertical scale in millirows by using the vertical scale control. The less millirows per division, the more detailed is your reflected waveform. The vertical position control positions the displayed waveform up or down the screen, and the horizontal position control moves the display's cursor. The noise filter control is used to set horizontal and vertical reference points and to reduce the noise of a displayed waveform. Noise reduction is scaled from 1 to 128. The higher the noise filter setting, the more time it takes to stabilize a signal. VP stands for velocity of propagation and is adjusted according to the dielectric of the cable you are testing. The left-hand knob adjusts tenths and the right-hand knob adjusts hundredths. For a cable with a VP of 0.78, you adjust the left knob to 0.7 and the right knob to 0.08. The main menu includes a feature called Help with Instrument Controls. Select this mode, and when a control or button is adjusted or pushed, a brief explanation of the control appears on the screen. You can get a paper copy of anything displayed on the tester's screen at any time by pushing print. When preparing to test a cable, consult the wire list and note the cable's length and impedance. Keep in mind that you never connect the live cable to the tester. Always disconnect any transmitter from the cable to be tested, and if the cable terminates at an antenna, ensure this antenna is not receiving a strong signal at its tuned frequency. Be aware of walkie-talkies and other transmitters in the area that can be picked up by the antenna and cause damage to the tester. Bleed the cable to be tested and any adapter cables before connecting them to the tester, and connect cables to the TDR through a static suppressor when available. With the cables properly bled and connected, you must then select the correct VP, or velocity of propagation setting. VP is the speed at which a signal travels down a cable and varies with different types of cables. Make sure you know the VP of the specific cable you wish to test, and set the TDR accordingly. This is crucial for determining the correct distance from the tester to any faults in the cable. You can find the VP of a cable by connecting a known length of the exact type cable to the TDR and adjusting the VP knobs until the end reflection matches the known length. You can then read the VP directly off the VP knobs. Most coax cables on AA aircraft have an impedance of 50 ohms and a VP of 0.66 or 0.78. Learning to read the TDR screen during a test is a skill that comes with practice. Your crew chief or supervisor should help you arrange for practice time with the tester and answer any questions you have. Again, Geeser GR7026 contains lots of helpful information. The first indication on the left of the tester screen is a test signal, or pulse, being sent down the cable. This test pulse is shown as a rise followed by a horizontal line across the screen. The next point where this horizontal line shows a rise or fall indicates a reflection of the test pulse. This reflection can be caused either by a fault in the cable or by the test pulse reaching the end of the cable. Since every test will show a reflection, whether the cable is good or bad, knowing the length of the cable you are testing will give you an idea of whether the reflected pulse indicates a fault within the cable or simply the termination of the cable. Place the TDR's cursor on the leading edge of the reflected pulse, and the distance along the cable to that reflection is displayed in the window. A good cable will show a reflection only at its termination, while a bad cable will show a reflection before its endpoint. Again, make sure you know the cable's length, impedance, and VP to ensure correct readings. When using an adapter cable, you must compensate for its length. Turn the noise filter control to horizontal set reference and position the display's cursor at the distance where the adapter cable connects to the aircraft cable. Push store, then turn the noise filter control to 1 average. The TDR now adjusts for the length of the adapter cable and reads the beginning of the aircraft cable at 0 feet. Some maintenance procedures require the calculation of the variable standing wave ratio, or VSWR. This ratio is found by noting the strength of the reflected test pulse in millirows, converting millirow value to a row value, and plugging that value into a mathematical equation. On the tester screen, look for a point where the test pulse shows a reflection. Using the vertical scale control, set the millirows per division to show a detailed picture of the reflection, and note this setting. A reflection set for 200 millirows per division will be twice as pronounced on display as the same reflection set for 400 millirows per division. Estimate the strength of the reflection in millirows. Convert that value into rows and plug the row value into the equation. 1 plus row divided by 1 minus row. The result of this equation is then expressed as a number in ratio to 1. If the solution to the equation is 1.5, the VSWR is expressed as 1.5 to 1. Compare the calculated VSWR against tolerances listed in the aircraft maintenance manual. The TDR is also useful for troubleshooting wire bundles. When an ohm meter reveals a fault in a wire bundle, the TDR can help you find the location of that fault. Using a wire adapter, connect one terminal to the wire with the fault and the other terminal to a known good wire within the bundle. The distance reading to the fault reflection indicates a logical starting point along the wire bundle to begin your physical search for the fault. With practice, you can learn to use more of the machine's features and also learn to recognize different waveform reflections. As a general rule, shorts in the cable are shown as a downward reflection of the test pulse, while opens reflect upward. Connectors, including the adapter cable connector, may appear as blips. Other faults such as wire damage, improper splices, even the presence of water can be identified by the shape of the test signal's reflection. Develop your skills by connecting practice cables with known defects to the tester and noting the results. Familiarize yourself with the TDR's many features and imagine work situations where they would be useful. Practicing with the unit under the supervision of a skilled operator is the best way to become an expert. The time domain reflectometer is a useful piece of test equipment, and its function is not limited to what's outlined in this program. Further study will give you a better appreciation of its capabilities. A full understanding comes from reading the appropriate maintenance documents, taking time to practice, and asking questions.